Next question is to find the area of the region that lies inside this one and outside the cardioid. Now for the cardioid, of course, we know the shape, right? We already used our tools to determine the shape of the cardioid, which goes like this, right? And how about this one? Now just by looking at this equation, we cannot predict its shape. Okay, so we have to use the techniques that we learned to determine the shape of this equation, and if you do so, you will see that it forms a circle like this across the y-axis, right? So putting both these things together, you can see that now for this one, the at well, this circle will have a radius of 1.5, right? So this cardioid will be inside the circle. So putting both the diagrams together, you will get something like this. So you are supposed to find the area on this region, right? On this region, this blue colored region. And also, now in order to find the area, we need to calculate these intersecting points. In other words, how do we find the intersecting points even in a Cartesian system? If we have two curves like this, right, then we get the equation of this curve and the equation of this curve, and we equate the two curves, because intersecting means it will have a common y-axis point, right? Common y point means this is expressed in the y-axis, so if they are common, this should be equal to the other curve, right? And then we have to find the corresponding x value, right, which is this point, and we have to do a similar process in here as well. So instead of equating y values, what we do is we equate the two r values, right? Because at each of these 2 points you will get a same r for this cardioid as well as for the circle, right? So we equate 3 sin theta to 1 plus sin theta, and that can, like here you can take sin theta to this side, so you will get sin theta minus 3 sin theta minus sin theta equals to 1. So you have 2 sin theta equals to 1, and that means sin theta is equal to half, right? So accordingly, we have theta equals to pi by 6 and 5 pi by 6. Now I should give you an advice. When you are doing these calculations, sometimes due to the repetitive nature of these trigonometric functions, you might get some additional angles. So it's a very good practice to draw the curves and see whether these angles are feasible, right? Say for example, if you get something like 90 degrees, it is not feasible, right? Or if it is a negative value, then you can, like, from your eyes you can see that there are no intersecting points in this region, right? So likewise, but here of course both these points are feasible, so easily we can have the 2 points. But it is not like, it will not happen all the time, right? When you are simplifying these trigonometric terms, you will get some unnecessary angles also, right? You might get some unnecessary angles, right? Okay, so now we have found the required 2 angles, and then what we have to do is we have to find the area of this region, and area of this big circle under this big circle, and the area under this small thing. And if you get the if you subtract it from each other, you can get the region in between, because the area of the big circle will be this one, and the area like this one, in the sense this total thing, okay, in the blue color, and the area of the cardioid within these two angles, that means within these two angles will be this one. Well, when it comes to the area, let me explain one more thing. Now remember, in the Cartesian plane, right, if you like if you say this is A and this is B and this is the x-axis, right, and if this is the function that depends on x, and if we take the integral from A to B of this function, that will give you the area from here to here, the x-axis, right, and we are integrating it with respect to the x, and we have the area in between the curve and the x-axis. But here remember, we are dealing with polar coordinates, right? So here what happens is we don't actually have this sort of x-axis, right? So what we will get is the area from this line up to this line, right? So it will not come below this line, right? Say if we use a general diagram, if we have a picture like this which is drawn from polar coordinates, and if we take angle theta 1 and if this is the angle theta 2, right, and if we integrate it from theta 1 to theta 2, what you will get is not something like this, okay, not at all like this. Like, you don't have to consider a point in the x and y, the x-axis, and compute the obtain the area from the curve up to the x-axis, right? So what you have to do is not what you have to do, but the meaning of this integral is the area in between these two lines and having the curve as a boundary, right? So this is the area that you will get by integrating, okay? So here also we will kind of limit ourselves from this in between these two lines, right? And when it comes to the cardioid, it will find the area in this region, and when it comes to the circle, it will find the area in this region. But for both the diagrams, you will not go below these two lines, right? Don't get these Cartesian area and the polar coordinate areas mixed up, right? Here Cartesian, when we are dealing with these Cartesian coordinate integrals and the areas, we are taking the area under the curve, and x-axis acts as the boundaries. But here the angles, the lines drawn for these particular angles will act as the two boundaries along with the curve, okay? So the difference between the area of this one and this one will give you the area in that intermediate region. Now then, once you understand the diagram, and when you compute the angles, that is pi by 6 and 5 pi by 6, then it's just a matter of computing the integral. So the area in between will be equal to this one, and here we can use one more simplification technique by looking at the symmetry of the diagram, right? Now it is true that this region lies between the angle theta equals pi by 6 to theta equals 5 5 pi by 6. But you can see that when you take the angle theta equals pi by 2, right, you will be getting the area of this region. If you consider the this uppermost endpoint as pi by 2, you will get the area of this region, right? And by looking at this symmetry, then if we can find the area of this region, then the area of this total region will be equal to 2 times the area of this one, right? So, and also dealing with pi by 2 is more easy when you have these trigonometric terms, right? So one method is you can just consider this one and compute the areas and substitute these upper and lower limits, or else you can consider the symmetry and compute the area by taking the upper limit as pi by 2, that is this one. See, here you have 5 pi by 6 and the only difference is pi by 2, and then you have to multiply it with 2, right? So anyway, when you compute these integrals, you can see that the simplification will follow like this, and the final answer is equal to pi. So that means the area of this region, this total region, will be equal to pi square units.